We have an object, it's a ball, that is connected to an end of a rope, and this object is rotating. I want you to imagine that this is a circle. Okay? And so this is the center of rotation, and the bob is actually rotating. And so we require to find the speed of rotation. So the speed of rotation is quite a very weird and different concept in circles, but it's really, really easy. Now, do you remember in physics when we were asked to analyze what the speed of a car was? What did we do? We brought the distance and we divided it by the time it took to cover that distance. And so if the car covered 20 meters in 10 seconds, that was 20 over 10. Your speed was an easy 2 meters a second. Well, how are we going to do that in the circle? The principle is constant. The principle still says distance divided by time. It's the same principle. But how are you going to do that in a circle? It's now a curved path. Well, the truth is there's no difference. In order to solve this problem, here's what you need to do. You have to bring the distance and divide it by time. Well, I didn't say anything different, but here's how we're going to do it. You're going to look into one revolution only. Just one cycle from here to here. And then you have the radius, am I right? So you're going to bring the circumference and divide it by the time it took to complete this cycle. Now the circumference is 2 pi r, and you have that divided by capital T. Wait a second. Now you will realize here we have a small t and here we have a capital T. Why is that? Well, small t denotes time. By capital T, I mean period. Now, if you don't know what this is, go and watch the video that I've spent talking about what a period and frequency are. But a period is how many seconds it takes for an object to complete a cycle. And so we have capital T down here at the bottom. 2 pi r divided by t. That will bring you your speed. All right? So away from the speed, this object is rotating at a constant speed, so we're not accelerating it, although there is centripetal acceleration and there is centripetal force. Anytime you have an object that's in rotation, there has to be a centripetal force and acceleration. And so this is moving at a constant speed. You are going to have centripetal acceleration pointing to the center. And this centripetal acceleration is denoted by AC. And it will mean, how will it be calculated? Well, there is a very long way of calculating it. But in the SUT physics, you have the formula, v squared divided by r. So let's do a problem. Well, we have a ball that is rotating. Radius is 10. Radius of rotation is 10 meters. And the frequency is 1 over 4 hertz. And we are supposed to find the acceleration, the centripetal acceleration. Well, when we go and solve this problem, we say, all right, A centripetal is equal to v squared, which is unknown. And we know the radius to be 10. So we got to find the velocity. Or we're not going to solve the problem. Well, how are we going to find the velocity? We're going to use the red pen. Hopefully this gives you an idea of how hard I work to make these videos as creative as possible. So we understand the frequency is 1 over 4 hertz. Now we need to bring the velocity, which is this right over here. I know the radius is 10. And so if I can bring the period, I'll be able to find the speed, put it over here, and be over with. Well, the frequency is 1 over 4 hertz. And because the period is basically the reciprocal of frequency, we know that period is 4 seconds. What does period equal 4 seconds mean? Well, that means that it takes 4 seconds for the object to finish a cycle. It's pretty slow, That wouldn't hurt if it hit you in the head. So we're going to bring the speed equals 2 pi multiplied by the radius, which is 10, divided by t, which is going to be 4. Which is that, well, that is going to be 20 pi divided by 4. And 20 divided by 4 is 5 pi. So that is your speed. So you go there. No, that was a really weird accent. I'm sorry for that. The centripetal acceleration would equal 25 pi squared divided by 10. That is equal to 2.5 pi squared meters per second squared. And that is how you solve the problem. See you in the next one.